Hi guys, it's your guy Holumde, and today we are gonna be solving another one of the most commonly asked tech interview question: the largest overlap of intervals. It is asked by top tech companies including Google, Amazon, Meta, Netflix, and other top tech companies. The problem statement states that given an array of intervals, determine the maximum number of intervals that overlap at any point. Each interval is half open, meaning it includes the start point but excludes the end point. The problem from the problem statement wants us to determine the maximum number of intervals that overlap at any point in time. That is the maximum number of interval that at a particular point in time have started but has not ended. So looking into this example that was given now, we see that at this point, this is the first interval. We are sorting them by their start value because this start at time 1, right? This one start at time 2. We see that before this one end, this particular one that start at time 1, before it end, this other one that start at time 2 have begin. Why? Because it end is still 3. Why? The start of this other one is 2. So we can say that's fine. These two overlaps. So, but now the problem statement wants us to return and determine and return the maximum number of overlap that can be found at any point. Fine, we know these two overlaps here at a point, right? Because at this point 2, there's actually two intervals that have started but never ended. But then we can see, even if we move further into our line and into the time, we can see that at this point we have 3 overlapping interval here that have started but never ended. Look at this one is in the range of 2 to 6. Fine, this it is half open, so we don't, but it is still open all along at this point, right? This is 2, so we can say that it's still open. And then if we look at this one here too, look at this one here now, this is one again that has opened but not ended. This is another one that has opened but not ended. This is another one that has opened but not ended. Fine, we're not going to count this one with it. No, we're not going to count this one with it. This particular one, why? Because it ends at this point. So it is ending at that point. So, but we see that at this point 6, right here, I mean at the time 6, we have one here that is opened and never ended. We have another one here that is open but never ended. And we have another one right here that is open but not ended. So this is the maximum overlapping interval that we can find at any point. So if we look into other points, it is not up to 3. Just like in this point now, this particular point here is just 2. But at this point, we have 1, we have 2, we have 3 intervals that have started but never ended. So in the example that was given to us in the problem statement, we can see that there are 3 active intervals that have started and yet haven't ended. So at this point 5, look at this point 5 now. We see this one has started, never ended, right? Even this one has started and never ended, and this one too has started and never ended. So at the point 6 as well, you will find out that we still have 3. This one has started and never ended. This one is has ended at the point 6, right? But this one has started but never ended. This one has started but, so they are just 3. So the maximum number is 3. So this means that to find the number of active intervals at any point, meaning that intervals that have started but never ended, definitely we need to find and we need to know when an interval starts, or when an interval has started and when an interval has ended, in order to be able to find the number of active interval at a given point 5. We need to find whether an interval has started and when it has started and whether it has ended. So, we can say that the start of an interval represents the start of a new active interval. So probably now, let's say at this point here, we only have 2 active intervals, right? This particular interval here, this one here, and this other interval here. This second one right here. So now that's what we have. But at this point 5, we see that a new interval starts, which is this one here, which is this last one at the top, that makes it 3. So the start of a new interval actually means a new active interval has been added at that point, while the end means a new it means a finishing. So of an active interval, that is, we have to what, reduce the active interval by 1 whenever it is finishing, but whenever it is starting, so we had one more. So it has been 2 all along, but when this third one joined, it becomes 3 active interval at the 0.5 that has started and yet are not yet ended. Because of this explanation, we can therefore suggest that we are gonna look based on when an interval started and when it has ended. So at any point in time, let's say 5 at the 0.5 or at the time 5, when an interval starts, if we can find an interval starting at that 0.5, then it is a +1 to the active interval. If it is ending, then it is a -1. So I hope you understand that. So we are gonna be solving this problem individually. So in the sense that, okay, we are interested in when an interval starts and when it ends. If it's starting at a particular point, we had one that, okay, we now have one more active interval. If it is ending, then we are subtracting 1, because look now, at this point 5 we have 3, right? At this point 6 now, this one is ending. So what happened? It becomes 2. Because this particular interval is ending, so the total active interval becomes 2, right? So but because this one is starting at that same point, it becomes 3 again. So, and that's how you see that from our previous discussion, like just some minutes ago, I told you that at this point 6 we have 3 active interval as well. So just the same thing as 5. And if you want to calculate it, this is the first one right here, 1. We are not gonna count this particular one, because it's ending at this point. So we're gonna count this one 2, and we're gonna count this one 3. So don't forget, this one is just an arrow. Actually, it's an arrow. So, and that's how we'll be solving this problem. So let's step through each point of the array in chronological order. I mean, we're gonna be stepping through the step 1, 2, 3, 4, 5 up to 8, right? Because we know that this actually represents either a start or a end. So what we want to do now is to straight through it and glance through it in chronological order. So we are not minding the start and finish of each interval now. We are not dealing with it that way. We actually just want to step through, because we know that if we move from at 1 now, we could have 1 active interval. If we move to 2, it's either we are having 1 more active interval, probably we are going to be losing 1 more active interval. So that's how we want to be calculating it now. We are not interested in per intervals. We're not interested in, look at this particular first interval now, it has a range of 1 to 3. So we are not interested in that range. We really want to traverse this chronologically. So let's do that now. Taking the pointer and setting it at the first position the first point now, it's 1, and at 1 we say that it is indicating the start point, right? Why? Because this particular interval is just starting at this point 1. So we have an active interval variable. We're going to increment it by 1, because now we have 1 more active interval at this point 1. So after doing that, now we proceed to the next point, which is point 2, right? Now at this point 2 again, we see that we have 1 more active interval, which makes it 2. It's a start point of an interval, right? So we have 2 active interval now so far. Don't forget, the problem is not actually interested at it's not interested in a point 2 or a time 2. He said that at any point, what we have to determine the highest number of active interval at any point. So at this point 2, we have 2 intervals so far. At the point 3 now, we see that an interval is ending. So it's gonna be a -1 for the active intervals now, and that's why we're having active intervals to be 1, right? So what are we doing now? We are progressing to the next point 4. So okay, moving to the point 4, we have another active interval, right? That is that makes it 2. Moving to the point 5, I have another active interval, that makes it 3. That's why you can see that the active interval at the point 5 is 3, right from the problem statement, from the example that's given to us, right? So that's how we do it on and on. Whenever you come across an active interval, we add the +1. Whenever you come across an interval starting up, a start point, we add 1 to the active interval. Whenever you come across an interval that is ending, it's a -1. So but we have to consider an edge case of whenever an active interval, when at a point, considering a point whereby an interval is starting and ending at the same time, right? An interval is starting and ending at the same time. So okay, the last time we talked, just now, we calculated our active interval at 0.5 to be 3. If you remember, just now I calculated it to be it's gonna be 2 right here at this 0.4, and at 0.5 it's gonna be 3 because we have another one active interval, right? So now let's proceed to the 0.6. Now we say that at 0.6 we have an edge case where we are not having just one of the two options. We are actually having both an end interval and a starting interval, an end point and a start point, right? So now let's say we process the start point first. This start point, let's say we process it first at this 0.6, right? We're gonna be moving from 3 to 4 because we'll be adding one to our active interval, right? Then if we now decide to process the end points later, after processing the start point, we then process the end point, which is here, because at the same 0.6 we are having one interval ending and one interval starting. So processing the start point first gives us 3, gives us 4 because the active interval is initially 3. Now processing the end point now give us 4, now give us 3, right? The active interval is 3. When you process the start point, we add 1 to the active interval to make 4. Now when we now process the end points, we reduce 1 from the active interval to make 3. And why we are doing this is because at this 0.6 there is a start point and a end point. There's an interval closing and an interval starting. So now you see that this is not this actually is not correct, because don't forget the problem statement asks us to return the maximum number of overlapping interval at any point. So if we process the start point first, it's gonna give us 4. We are gonna record that 4 as the maximum. Don't forget that we are actually interested in the maximum. So if we move to another point and it's less than 4, we are not gonna take that as the maximum. We're gonna take 4 as the maximum so far, right? So, and that is gonna be a mistake, even though it's going to return back to 3 because we're gonna subtract 1 because of this endpoint, but it's still gonna record 4 as the maximum. So but if we process the endpoint first, we have our active interval to be 3 by default right from the 0.5 here. So coming to 0.6, if we process this endpoint, this point right here, this one, this interval that this particular one right here, this interval that is ending, if we process it first, then we're going to be having 2 because we'll be subtracting 1 from the active interval. If we now eventually process the start point, now we're going to be having 3. So that way we won't be able to record 4 as the maximum. You see that this is quite fine. So for an edge case whereby we are having a start point and an end point, what we want to do is that we want to process the end point first, followed by the start point, so that we are going to have a correct maximum. Now we need a way to iterate through the start and the end point in the order that they should be processed. What I mean is that, right, you see that in this logic we start from this point, which is the first one, then we move on chronologically. So it is not gonna be given to us that exact way, don't forget. So it's just gonna be given to us in this form. In the interval form is an array of interval. That's what the problem statement told us. So now we need a way how to convert it such that it's gonna so that you'll be able to apply this logic to it. And what I mean by this logic is that so that we'll be able to traverse through it chronologically from one point to another point, and then adding to the active interval if it is a start point, removing if it is a end point. So how do we do that? To do this, we are going to combine the whole start point and end point into a single array and sort it. Right? You might be like, okay, what I'm trying to say is that, okay, we are going to combine this array. You see that we have this array of intervals 1, 3, 2, 6. We are going to sort it into a single array. So it's gonna be, and we're gonna sort the array. So it's gonna be 1, 2, 3, 4, 5. Just like this. And why we are doing this is because we want to navigate through it chronologically. So we are not interested in start and end, start and end, start and end, start. We just wanna, if at a point is a start, add the active interval to add 1 to the active interval. If you go on to the next point, if it's a plus, if it's a start again, I want to just know the maximum active interval at a particular point. If it is a minus, subtract. So because of that, to use that logic and implement it in code, we are gonna be taking this interval and then converting it into a single array, and it's going to be sorted. So, but you know that at each point we really need to find that if it is a start or a end. So that's why we have to find a way to designate that each of these sorted lists now of combined start and end in chronological order. We need to know if it is a start or an end, and because of that, after sorting, we are going to say 1 is a start. Why? Because this interval 1 is a start here, right? Then 2 is going to be a start as well. So meaning that at the point 2 now, I mean as we traverse through these points now, this particular point, when we get to this index 2, we know that we now have 2 starts, so our active interval will be 2, right? When we come to 3, it's an end, because that 3 corresponds to the 3 that is here. So we will know that an interval has ended here. So as we traverse now, we know that the intervals at this point is now 1 because it was actually 1 here, 2 here, but 1 ended at this point, so it's now 1 back. So along the way, don't forget, we'll be keeping track of the maximum at any point. So don't think that we're gonna keep track of 1, that we're gonna record 1, just 1 like that. We're gonna have a maximum intervals, like a variable that will be keeping track of. Now so far the maximum variable will be 2 because it has been 2, even though it decreased to 1, right? But the maximum is gonna be 2 because the problem asks us to determine the maximum overlapping interval at any point. So when you come up to 4 again, it's gonna be a plus, right? Which is it's gonna be a start, because 4 corresponds to start, a starting point here. So 5 2 is gonna be a start. 6 is gonna be a start. Okay, now the edge cases that I explained earlier, the edge case I explained the other time, that what if we are having a end and a start point and a end point at a particular point. So we said that we are going to deal with this end first before the start. So that's why you see that even though 6 appear as a start and the end, when we are trying to work on it now, we put the end first before the start, so that so far from here we are going to have 3 active intervals from our discussion, the logic we explained. So and coming here is going to become 2 because this is the end point. So and coming here is going to become 3 again. So that way now we won't be able to record 4 or a bad number in our, we won't be able to store it. So we'll only be able to store 3, because if had it been this place is a start point, had it been the start point comes before the end point, it's gonna be 4. Meanwhile, it's never 4. So coming back here now, this is the end point, this is the end point, this is the end point. So how are we gonna solve this problem now? So this is how we're gonna solve it. We're gonna take our intervals that is given to us, we're gonna convert it into an array, we are gonna sort it, we are gonna then find the way of making sure that each of these points here, each of these points will be a start or a end, and we can do that using a tuple. So and then we'll see more about it in the code implementation actually. So and this algorithm is actually called the sweeping line algorithm. The sweeping line algorithm. So we are going to be going to the code implementation now. So follow still. Alright, let's go into the code implementation for the largest overlap of intervals. So we have this function, we're going to be calling the function largest overlap of intervals, and it's going to be taking in an intervals, so which is a list of lists of integer, right? So because that's what will be given, and it's gonna be returning an integer, which is the maximum overlap, the maximum overlapping interval at any point. So right, so this is the parameter actually that will be collecting. So you see there is a list of integer. So right now, in solving this problem, we say we are going to be needing the some variable, which is the active interval, that will help us to be calculating the active interval as we navigate through chronologically through the through each point. I mean from the point 1 here to the point probably 8 or any highest number of points. So we'll be adding 1 to the active interval when we are supposed to add it. That is, whenever we come across and encounter a start point, we'll be subtracting 1 whenever we come across an end point. So we'll also be having the maximum active interval. So because as we are navigating through the active interval, we don't just want to return anyhow active interval at any point. We want to return the maximum that has been found so far. So, and also be dividing the points that will help us to be to rearrange our active interval in chronological order. Don't forget that in this order they come in form of interval, start and end, but we really want to navigate them chronologically. How many active interval are there in point 1, point 2, point 3, point 4. So we'll be having this list of points. And okay, let's iterate through our interval. For interval in intervals, so what we want to do is that we want to be appending both start and end. Points dot append. We want to append both start and end so into our interval. So and now we have to create a delimiter that will tell us that okay, this particular point is a start or is an end. So point dot append interval of 0, right? Because interval of 0 is a start, is the start point for the interval. Why point dot append end comma interval of 1. That's the end point. Now that we have it appended, we want to sort it now in chronological order. So we're gonna say points dot sort key is equals to a lambda function lambda s, such that when we say point actually consists of this tuple. Don't forget, now we have appended tuples into our point, so we want to sort it based on their value. So 1 should come before 2, 2 should come before 3, right? So s, that's why I'm gonna say s of 1. So I'm not gonna say comma s of 0. So you might be wondering, why do I have to put s of 1 comma s of 0? Why I do that is because, first of all, I want to sort this particular point, which is a tuple. Don't forget, we are appending tuple to the point. So I want to sort it based on their interval value, meaning that the start point, the first value should be 1, followed by 2, should be chronological, right? Fine. And then from the logic, it's gonna be chronological. Why? Because at the point 1, we want to know which particular interval is starting or which particular interval is ending, so we can add or remove from our active interval. So then we move on to the next interval and to the next point, which is point 2. So we want it to be chronological. Why we are now putting comma s of 0 is because in a situation whereby both there are two intervals, that has the same value. Like, look at this case now. This is 6 and this is also 6. So similarly, this is 7 and this is also 7. In cases like that, we want to sort it based on their end and start point. We want the end point to come first before the start point. Then I put s of 0 there. So doing that now, we now have our point that consists of tuples of start points and of the points, maybe a start point or a end point, and their interval. So we are going to iterate through our tuple now for points in points. And what we want to do is that we know that it has been sorted, so we know that it's either going to be a start point or a end point. So if point is a tuple, so dots if point of 0, right? So point of 0 is going to tell us if it's a start point or not, if it's equals to s. So what we want to do is that we want to add our active intervals. So active interval plus equals to 1, else active intervals minus equals to 1. So that's just simply what we want to do. So we iterate our point, try to check if it is a start point, we increase our active interval. If it's an end point, we reduce our active interval. So but before we move on to the next point, we want to make sure that if this particular active sum, if it's our we want to try to check if it is the maximum active interval so far. We are trying to track the maximum, so we're going to be using maximum of maximum active interval, comma the active intervals. So right, okay, so that's it. We are trying to track if it is the maximum so far. So and now let's run the code and see how it goes. Oh, when I run the code, I think we made a mistake here. Right here it's supposed to be just one list, not two. So let's run the code again. So because we are iterating through our intervals, our array of intervals, right? So we just want to get the, as we iterate through the array for each of the intervals, I just want to get the first element. So instead of having to put the curly braces twice, it's just meant to be one. So let's run and see what else we have done. Okay, at this point as well, append takes exactly one argument, but two were given. All right, let's look into it. Yeah, sorry, I'm supposed to append a tuple. It skipped my mind. So we are supposed to append a tuple right here, just like we did at the top. So that way we can iterate through our points and try to check if it's a start point or a end point, and we are gonna add to our active interval or subtract respectively. So let's see what happened now. Okay, actually none is returned, and the reason is because, I'm so sorry, we actually do not return the maximum active interval at the end. We do need to return that. So run the code again, let's see. Alright, 3 is returned now, which is the correct answer. 3 is returned. So, and why it is 3 is because here from the problem statement we can see that it is 3 because you know, at the point 5 we have the maximum to be 3, we have the maximum overlapping interval to be 3. Even at the point 6 is still 3, right? So that I solved this problem. I'm so sorry for any delay, or so sorry about that, and I hope the errors and and the whole box teaches us a lesson. So thank you, and anticipate my next topic. It's gonna be on a very new, different problem solving techniques, the prefix sum. So stay tuned. Do like, comment, subscribe, please, and please. Thank you.